Hello friends, we start with the next point, that is the next type is priority queue. This is the last type of the queue, that is a priority queue is a data structure in which each element is assigned a priority. Now see here, this is somewhat different as we are dealing with different types of a queue, or as we have studied with different types of a queue. Now here we have to focus on the priority of the element which comes inside the queue first, which is served first and executed. So it's like a stack. Okay, the priority of the element will be used to determine the order in which the element will be processed. This is quite obvious that priority means for which element we give the more important than the lesser element. So with the help of that we decides, or the program decides, the priority that which element served first. Okay, so the general rules of processing the elements of a priority queue are now, as we are designing the priority queue, what type of rules we have to consider, that we have to dealing with. So the first rule is an element with higher priority is processed before an element with a lower priority, as we have to consider the priority concept. So we obviously follow the element which is having the highest priority. Two elements with the same priority. Now there is a confusion that if there are two elements with the same priority occurs, now in that case what we have to do? So we are processed on the based on first come first serve. So whichever come first inside the stack, okay, that is to be served first, and the next one served after that. So we are following their FCFS rule, that is first come first serve basis. So according to that, keep in mind that as the name suggests, a priority queue means we are handling the element based on the priority. Now what is the implementation of priority queue, or to implement the priority queue, what are the different ways to handle the priority queue? So there are two ways to implement a priority queue. We can either use a sorted list, okay, list which is already sorted, the elements which are present that are already sorted by using different sorting techniques that we have to study. After linked list, we have to study that what is searching and sorting. So by using different sorting algorithms like bubble sort, merge sort, insertion sort, quick sort, etc., we can sort the list first to store the elements, so that when an element has to be taken out, the queue will not have to be searched for the element. Okay, so here we are not in a position to search any element from the queue. We are already sorted that elements. We just want to taken out the element which is having the highest priority, and if the two element is having the same priority, then we go for FCFS basis, that is first come first serve basis. So the queue will not have to be searched for the element with the highest priority. Or we can use unsorted list, so that insertion are always done at the end of the list. Or we can use the unsorted list also. So insertion always put at the end of the priority queue. So these are the quick, what we can say, the quick review of a priority queue. The implementation of priority queue with two types, that is link representation of priority queue and array representation of priority queue. When a priority queue is implemented using a linked list, then every node of the list will have three parts. Now any technique or any what uh, any topic that we want to implement with the help of linked list, we have to consider the data part, the address part, and the content which are there in the linked list. So here also every node contains three parts, that is the information or a data part, the priority number of the element, and the address of the element. The address of the next element where we are pointing the address of the next element in the previous element. So that is the same concept that we studied in the linked list chapter, or that we want to study in a linked list. After priority queue or after stack and queue, you can understand what is linked list. Linked list is showing in the figure 8.25 contains the data in the first part, data namely as A, B, here A, B, C, D, E, F. These are the data part. And the link here represent the link between these two node. This is one node, this is second node. The link between these two nodes, so that by using this previous element we can point to the next element. How we are pointing? We are pointing with the help of address which is stored in the last field of this node. So that we will be study in detail in the next linked list chapter. Up till only consider that this is a node contains a data part, that is information, the priority number, that is 1 2 3 4 5, and the address which points to the next node. If we are using a sorted linked list, sorted array, sorted queue, in the similar manner sorted linked list. Sorted linked list, arranging the element in a ascending order or descending order. It should be ordered. It is not messed up elements, these are to be ordered. Then the element with the higher priority will be precede the element with the lower priority. Now for this, I will take this figure which clearly explain you, that is the element or the node which contains A as a data or information part, having the priority number 1, which is at the highest priority by considering this figure, as compare with the data part B, which is having the lower priority than first element. So whenever we are using linked list representation for the priority queue, we are representing in the manner which is showing in the figure. Now the next part which implements the priority queue is array representation of priority queue. Now how array help to represent the contents with the priority? As we know that priority queue is completely focused on the priority, as we also discussed in the linked list representation of priority queue. In the similar manner, here also we are focusing on priority by considering array representation. When an array are used to implement a priority queue, then a separate queue, for each priority number is maintained. is maintain. Each of this queue will be implemented using circular array. Using circular array or circular queue. The circular queue we are already discussed in the previous slides. So you understand what is circular queue, and that circular queue itself we are using to implement the priority queue by using array representation. Now in front of you there is one figure which represents priority queue matrix. In this, every individual queue will have its own front and own rear pointers. We know that from the rear end we insert the element. So whenever we are inserting the element or deleting the element, from front we delete the element from the queue, and from rear we insert the element inside the queue. So here we are inserting and deleting the element by considering the priority of a number, and for each element we create an individual priority queue, and we are performing various operations, that is insertion, deletion, on the priority queue. Here front of k and rear of k contain the front and the rear values of row k, and here where k is the priority number. So this is very simple representation of a priority queue, and in this two manner we can implement the priority queue in a data structure. So with this we end with this topic of priority queue from the chapter Stack and Queue. Thank you.